Hey Edgar, how are you?
I'm doing great, Steve. How are you?
Good. Actually, I'm really excited to talk to you today because our chat today is going to be about something much more fundamental. It's actually like the physical infrastructure which supports telecommunications networks, the pipes, the towers, and things like that. I guess there's a lot to understand about the physical materials that are used, different types of metals, for example. I mean, there's more to it than that, though, isn't there?
There are some invisible parameters to the bare eye that are also considered heavily from maybe I'll say technical teams that are overlooked by people out in the field or people actually carrying the items and putting them together.
How might a bad selection of material manifest itself over time in a network? Let's say with either pipe or with a tower, for example.
I think that's a great question, and I'm going to use this spring to make the analogy. So, this spring right here is made out of some metal, and I can come and just ever so slightly pull on that spring, and it's going to extend a little. But the thing is, as I let go, it's going to snap back to its original position. So, it's retaining its properties. Now, if I were to pull on the spring far out enough, it will pull far out enough, but it will permanently get damaged or permanently deform. It's not going to retain its original size and properties anymore. Now, any material in the world has that point. It's that point in which if I stay under, I am going to retain the properties just fine. But if I cross, I'm going to permanently damage the material. And this is important in steel pipe because the point changes based on material grade. So I am making assumptions regarding a certain grade I need to use on the structure, but then maybe that got swapped out or interchanged with something else that looks the same that has a lower point or grade, and that got installed. You can have two steel pipes before you that look identical in shape and in size, but they're not necessarily the same because there's the underlying invisible factor called the material grade that could be different. They could both still be steel, they're galvanized, they're silver in color, they have the same OD and wall thickness, but the material grade is different. And because of that, they may go ahead and think these are interchangeable and replace one with the other. So the disconnect is I, maybe as an engineer or as a technical guy, made some assumptions in the software or in the analysis side of it. And then what got installed is different because of the physical looks. And that disconnect is going to obviously end up being vast in the reliability of the structure itself. The thing is, you come back in 6 months, a year, 2 years, and because it's a different grade and a different point that got crossed, then you start seeing issues like mounts and structures sagging or, God forbid, maybe falling apart and just getting damaged.
First of all, thank you for drawing our attention to this really critical issue in telco infrastructure. But what is the answer?
That's the $1 million question, right? So, unfortunately, in reality, there isn't really a way to physically tell the material grade. That's just how our world works. But as Andrew, we are trying to come up with alternative ways for that definition to be in place. And an example of that is documentation and traceability. What we're doing is we're slapping labels on pipes that essentially identify everything. They say the part number, they say the geometric properties like the outer diameter and wall thickness, and they're saying the material grade, and they specifically define what grade it is. So for the installer and field crews, they can look at that and directly tell whether this is correct for the application or not. And another avenue we have is we have an online portal that the crews can create an account on. And there's databases residing in that portal where they can go and match the drawings they get, the assembly drawings, kind of like a piece of IKEA furniture. They get something similar for the mount to put out there. And there's part numbers and steps to put everything together. And so when they come to the pipe, for example, they can match that part number in the database to confirm that the material is correct. If what they're seeing doesn't match for any reason or feels wrong, that's a direct way for them to just stop and figure out what's going on there.
Listen, Edgar, thank you. What a pleasure. It's nice to talk about something physical and important that's happening in telco as opposed to software for once. So I really appreciate you sharing all of this important information with us.
You're most welcome, and thank you very much for hosting me today.